Okay, natural logarithmic function integration. So we differentiated in 5.1. We need to integrate in 5.2. So the derivative of the natural log was 1 over x. Or in general, we were using this, correct? Okay, so we have u prime over u, or the du. You can write it the long way, or you can write it the short way, and this is how we like to write it, right? Derivative of u over u. So let the differential function, the integral of 1 over x, well, 1 over x obviously would be the natural log of x. The one thing we're doing here is we're doing the absolute value of it. So you just need to remember where to put that in there. Because remember, logarithmic functions, the domain is 0 to infinity. So you can't have a negative number, so you have to have the absolute value. But in general, this is our general right here. So this is what you need to write down. The integral of u prime over u. So if you have a fraction and the derivative is the numerator and the denominator is the, does that make sense? Yeah. Then you're using natural log. How easy will that be? Easy. Really easy. So it's just the natural log of u plus c. So I put all the boxes that the book has, but this is what we're going to use. And you hope it's that, because that would be so easy to do, wouldn't it? So we're hoping. It won't always, but. Okay, so we have 2 over x dx. So u would be?
U is x.
X, because it's a denominator. And u prime would be 1. Yep. So in order to get that, it was 2 times. And then it would be 1 over x, wouldn't it? Yeah. Dx. And so since we have the derivative over, we have u prime over u, we just have 2, the natural log of the absolute value of x plus c. Yep. That kind of went really quick, but did it go too quick? Okay. So on the next one, what would u be?
4x minus 1.
So 4x minus 1. So u prime would be 4. Well, we don't have a 4, but we have a 1. So how did 4 turn into 1? We took a fourth of it. So 1/4 the integral. And now I have u prime over u, don't I? Du. So then I have 1/4 the natural log of the absolute value of 4x minus 1.
So it's always going to be just your regular u in the...
Yes, it's the integral is
1.
The integral is u. Okay?
Yep. That's easy.
Mm-hmm. Okay. In this example, we will use an alternative form of the log rule. Look for quotients in which the numerator is the derivative of the denominator. Okay? Always look for that. Okay, so it says find the area under the region. So area was the integral, correct? So we're going to do the integral from 0 to 3. Remember that rule was well, we'll do f of 3 minus f of 0. Okay. I was trying to figure out how to do it. Okay, so we have the integral of x over x squared plus 1 dx. Okay, so u would be x squared plus 1. So u prime would be 2x dx. Okay, so we're missing their 2, so we're going to have a half out in front, aren't we?
Yep.
So we're going to have 1/2 the integral from 0 to 3 of, then we have u prime over u.
Yeah.
So then if I have u prime over u, then it's natural log. So I have 1/2 the natural log, the absolute value of u, which is x squared plus 1, from 0 to 3.
Yeah.
Okay. So when I plug that in, I'm going to kick that 1/2 all the way out. I'm not going to distribute it. I'm going to leave it out. So I'm going to have, oops, just a second, my screen went tiny on me. So 1/2, and then I have to plug in 3. So 3 squared plus 1 would be 10. And I don't need the absolute value anymore because it's a positive 10, correct? And then I plug in 0, so minus the natural log of 0, which you should know the natural log of 0 is 1. Remember, because anything to the 0 power is 1 in inverses. So I now have 2, the natural log of 10 minus 1. And if I need to, I would put that in my calculator.
Yeah.
And do we need to put it in the calculator? You good with saying that exists, but no,
So on homework, you just want us to come up with that, we don't have to?
you don't have to. Now, and you should be able to check your answers. They should have this as an answer before the approximate, so. Okay. I'm just checking what I have. So I just have like all sorts of examples. That's all I got. Okay, I think that was the slide, wasn't it? Yeah.
Yep.
Okay, so I have 3x squared plus 1 over x cubed plus x. So if we're going to use natural log, the denominator is going to be your u. So that's it, easy. So u, u is x cubed plus x.
Yep.
So u prime,
It's 3x squared. Yes.
nope, plus 1
Oh, yeah.
dx. Okay, so are we in good shape?
Yep.
Yep. Because we have u prime over u. Perfect. So since I have u prime over u, then it's the natural log of the absolute value of x cubed plus x plus c. It always feels like, what else do I need to do with natural log? But you want it that because it's easy. Now, I'm going to remind you, though, is it always going to work? No, because we will try to make it work when it doesn't work, and sometimes get ourselves in trouble. Okay, so if we're going to use natural log, what our u better be what? Tangent. And what is the derivative of tangent? Secant squared, isn't it?
Yeah.
Where's your sheet? Well, if this is going to work, it better be secant squared, right?
I think
It is. Okay, so what's my answer then?
well, it's just natural log tangent
Absolute value
absolute value.
of tangent of x. And the trig ones, we always try to make them harder too, because they're like, where did it go? Well, it didn't go anywhere. That's the rule, isn't it? Okay. I think you should try these two on your own. Oh, wait. Okay. Did you get those two answers? Did you get this answer?
Yeah, I got those.
And
I
this?
just didn't take the
Okay.
half one third.
So why are these the same answer?
Because you're putting it back.
Right. It's because it's the logarithmic rules, right? It's the properties of logarithms. I don't care which one you do. I'm fine with either way. If I'm going to have to input it, like go from 0 to 3, I'm leaving the 1/2 out front. Until I have to put it in. Does that make sense?
Yep.
Okay. And they have it, it's either you can write it like this or you can write it like this. It doesn't matter. My preference is this way. Okay. Questions?
Nope.
Concern? Okay. Okay, long division. Okay, we are going to use long division. I'm going to tell you exactly why. When the numerator is greater or equal to the degree of the denominator. So, long division, when the degree, I don't know why I put a G. Of, can I say just n of x and d of x?
Yeah.
N of x is greater than or equal to the degree of d of x. Because we're used to n of x and d of x from graphing things, right?
Yep.
Okay, so, and that, when we did, like when we were doing limits with these, remember we were supposed to divide by the highest power in the denominator when this happened. So when we see this, we should immediately, anytime we have something that looks like this, should we try to reduce if we can?
Yeah.
Yes. Okay, so we're going to use long division to do so. So we have x squared. Don't forget to put your placeholder.
Yeah.
And then x squared plus x plus 1. So x squared times 1, right? So that'd be here. So then we multiply by -1. So negative x squared minus 0x minus 1. So that just gives me x. So now what I have then is I have the integral of 1 plus, what's your remainder? X over your divisor, x squared plus 1. Makes sense what just happened?
Yeah, we do all.
Because it's your quotient plus your remainder, isn't it?
So our remainder is just replacing the u prime.
Yes.
Part? Okay.
Yeah. Okay, so that now this, we're going to do the integral of this and the integral of this separately, correct? The integral of 1 is x, isn't it?
Mm-hmm.
Okay. So this is x plus, well, here u would be x squared plus 1